NASA is concealing a startling secret about the moon, one that could revolutionize our understanding. The moon is not just a barren wasteland of rocks and craters. Something far stranger is happening. Water on the moon seems to move in an inexplicable cycle, appearing and vanishing mysteriously. Even more perplexing, it survives the extreme temperatures of the moon's surface, both the intense heat and the freezing cold. What NASA has uncovered in the moon's shadows could reshape the future of space exploration. For decades, scientists have been on a quest to find lunar water, and their discoveries only deepen the mystery. The moon isn't supposed to have water. Its surface is relentlessly bombarded by the sun. Temperatures fluctuate between blistering heat and freezing cold, and without an atmosphere, water should simply escape into space. Yet, water keeps appearing in places where it shouldn't. But could there be more hidden beneath the moon's surface that could change everything? In the 1970s, the Soviet Union launched the Lunar 24 probe to the moon's surface. It drilled about 2 meters into the lunar soil, collected samples, and sent them back to Earth. When scientists examined the samples, they were astounded to discover traces of water. About 0.1% of the soil contained water, and the deeper they drilled, the more water they found. Most experts initially dismissed the findings, attributing them to contamination from Earth. However, by the 1990s, NASA's Clementine mission began to investigate more thoroughly. The mission conducted scans of the moon's surface, uncovering craters near the South Pole that had been in constant shadow for billions of years. These areas were so cold, around -173°C, that any water ice trapped inside could remain frozen indefinitely. NASA wasn't content to stop there. In 1998, the Lunar Prospector spacecraft surveyed the poles and detected significant amounts of hydrogen, possibly linked to water. The findings suggested there might be as much as 300 million tons of ice hidden in the craters. However, hydrogen alone couldn't confirm the presence of water, as it could simply indicate hydroxy, a chemical similar to water. To clarify the situation, NASA purposely crashed Lunar Prospector into one of the craters, hoping to release any ice, but the results were disappointing. No ice was found. In 2007, Japan's Selene spacecraft attempted a similar approach, yet still no water was detected. Despite this, the findings raised new questions. Why hadn't the water evaporated? On the moon's sunlit side, temperatures soared to 127 degrees Celsius, hot enough to destroy electronics, while the shadowed areas plummeted to -240 degrees Celsius, colder than anything we've measured in the solar system. But recent data reveals an even more puzzling scenario. The Lunar Reconnaissance Orbiter, LRO, discovered water molecules scattered not just in shadowed craters, but across the moon's surface. Even stranger, this water seems to behave in a peculiar way. It vanishes during the day and reappears at night, almost as if it's part of some lunar water cycle. Scientists have proposed theories, but there's no definitive explanation yet. One idea suggests that micrometeorites might be constantly striking the lunar surface, depositing tiny amounts of water with each impact. Another theory involves the solar wind, which could be reacting with the oxygen in the lunar soil, creating water-like molecules. These molecules might get trapped inside glassy beads formed by meteorite impacts. Regardless of the reason, this discovery has major implications for future space missions. It could mean astronauts wouldn't have to bring water from Earth, but instead could set up mining operations to extract it directly from the moon's surface. One crater, measured by the Lunar Reconnaissance Orbiter, LRO, recorded temperatures as low as -250 degrees Celsius, the coldest ever observed in the solar system. Such extreme cold could potentially damage spacecraft and freeze equipment solid. But here's the twist. What if accessing this water is harder than we expect? Some experts fear it could be deeply embedded within tiny grains of soil, requiring complex and costly extraction methods. Others argue that the moon's harsh environment could pose too many risks for long-term missions. And then there are the conspiracy theories. Some claim that NASA and other space agencies already know far more about lunar water than they're revealing. After all, if there's enough water to sustain life, it could revolutionize our understanding of space exploration and even prompt us to reconsider the possibility of life beyond Earth. NASA has long been the leading name in space exploration, But what if there's more going on than they're sharing? Things might be stranger than we think. Strap in, because this isn't your usual science lesson. This is about hidden truths right in front of us and why everyone suddenly wants a piece of the action. First off, certain areas are colder than Uranus, Neptune, and even Pluto. Hard to believe, right? Deep craters with edges so sharp they block out sunlight have essentially become natural freezers. Scientists have long speculated that these dark regions might be storing ice, but that's just the beginning. Along with frozen water, they've discovered traces of carbon dioxide, carbon monoxide, nitrogen, and argon. And then, it got even stranger. NASA's SOFIA telescope, a flying observatory, detected water on sunlit areas. Wait, what? Water where it shouldn't be? They focused on Clavius crater, one of the largest craters visible from Earth, and found water molecules scattered in concentrations as low as 100 to 400 parts per million. For context, the Sahara Desert has about 100 times more water in its soil than that. So why is this important? Water isn't just a necessity for drinking. It's like space treasure. It's essential for growing plants, supporting colonies, and perhaps most excitingly, fueling rockets. When water is split into hydrogen and oxygen, it becomes rocket propellant, making space launches much more affordable compared to launching from Earth. With only 1/6 of Earth's gravity, the Moon is essentially a launch pad just waiting to be developed. With valuable resources like water and other compounds within reach, it's transforming from a barren rock into an exciting new frontier. China and Russia are already planning missions to establish robotic bases near the Moon's south pole by 2030. Meanwhile, NASA's Artemis program is working to send humans back to the lunar surface for the first time since 1972, and they're aiming for more, a permanent base. The Moon's untapped resources, like helium-3, could completely change our future. If you're a fan of sci-fi, you've likely heard of helium-3. It could fuel nuclear reactors with minimal radiation and waste. It's also useful in medical imaging and radiation detection. But here's the challenge. Earth doesn't have much helium-3. There are small amounts in natural gas, but extracting it is both costly and inefficient. Helium-3 can also be produced as a byproduct of nuclear weapons production, but let's face it, no one's eager to escalate nuclear arms just to make fuel for reactors. That brings us to the lunar surface, where helium-3 has been accumulating for billions of years due to solar winds. However, don't get too carried away. It's still quite rare, present at only about 50 parts per billion in lunar soil. On the plus side, because it's spread evenly across the surface, mining it alongside other materials could make the effort worthwhile. Countries like China, the US, and even private companies are eyeing helium-3 as a potential energy source for the future. If it pans out, we're looking at a clean, limitless energy supply, which would be a game changer. And helium-3 is just the beginning. Lunar soil, or regolith, is packed with valuable metals such as iron, titanium, aluminum, and magnesium. Breaking them down could also yield oxygen and hydrogen, key elements for breathing and fuel. Regolith could even be turned into building materials like lunarcrete, reducing the need to transport supplies from Earth. To top it off, it holds rare earth metals, the very same ones in your phone, laptop, and electric car. While these metals aren't exactly scarce on Earth, they're spread thinly, making mining expensive and messy. Lunar deposits, however, could be easier to access, potentially making the Moon a gold mine for tech companies. With all these resources, the idea of establishing a permanent lunar base seems far more feasible. Sustaining a colony that produces its own food, mines its own fuel, and manufactures its own materials is a fascinating prospect. Plants could even grow in lunar soil, although hydroponics might be the safer approach for large-scale farming. However, before we get too carried away with the idea of lunar towns and space tourism, several key questions must be addressed. Who owns the Moon? Existing treaties state that no one does, but as nations and private companies start to establish operations, these rules could easily be challenged. What happens if mining activities harm the lunar environment? Unlike Earth, we can't simply undo damage later. As space exploration becomes the next big frontier, the line between exploration and exploitation is becoming increasingly unclear. Are we witnessing the beginning of a spacefaring civilization, or is this just the latest gold rush? The reality likely lies somewhere in between. Mining helium-3 and rare metals could unlock advanced technologies, but it also raises significant ethical and environmental concerns. One thing is certain, the moon isn't just a barren rock. It's a treasure trove waiting to be tapped. Whether we use its resources responsibly or repeat Earth's mistakes remains to be seen. What is clear, however, is that NASA and other space agencies aren't revealing the full story yet. As missions intensify, expect more secrets to emerge from those lunar craters. Consider this. Earth is running low on rare metals, the kind that power our phones, electric cars, and satellites. And who controls most of it? China. They dominate the market, holding nearly 1/3 of the world's supply and providing over 95% of it globally. It's a monopoly that's as tight as it gets. Extracting these metals from the Earth is no easy feat. Pollution, destroyed ecosystems, and the hidden human costs are uncomfortable truths that we often ignore. Still, our demand keeps growing, especially as electric vehicles become more widespread. So, the big question is, where will we source the next major supply? This is where things get complicated. Mining operations require water, not for drinking, but for producing rocket fuel by splitting it into hydrogen and oxygen. While water ice has been discovered at the poles, trapped in craters that never see sunlight, accessing it is a daunting challenge. The environment is brutal. Temperatures fluctuate dramatically, and the ground is coated with regolith, a sharp, abrasive dust. This dust sticks to everything, damages spacesuits, and has the potential to short-circuit electronics. Astronauts from the Apollo missions reported it clinging to their gear like stubborn glitter that never fully comes off. And that's not even the worst part. The poles have an eerie electric field. Solar winds striking the surface generate static charges that can accumulate to thousands of volts. Picture stepping into one of those craters and being struck by invisible lightning. It's not sci-fi. It's a real scientific concern. Engineers are racing to design spacesuits capable of withstanding this, but they aren't ready yet. Until then, venturing into these regions is like walking through live wires. But it gets worse. NASA's major plan to explore the poles just hit a major roadblock. Their Viper mission, a rover designed to search for water ice, was initially set to launch in 2023. After delays, it was rescheduled for 2025, only to be abruptly canceled. Millions of dollars and years of research have gone down the drain. Without Viper, the search for water ice is at a standstill, while other nations are moving ahead. India, Russia, and private companies like SpaceX are eyeing the prize, ready to jump in, while NASA falls behind. Mining could be the key to solving Earth's resource crisis, but it's not as simple as loading rockets and hauling resources back. The space race isn't just about planting flags, it's about control. Control of vital resources, advanced technology, and possibly even the future of humanity. In August 2022, South Korea launched a probe named DENRI. It took nearly 5 months to reach its destination, but by December, it was in orbit, circling like a hawk. What's fascinating is that NASA partnered with South Korea for this mission, offering resources, technology, and scientific guidance. In return, South Korea allowed NASA to attach an advanced camera called ShadowCam to the probe. Sounds simple, right? But here's the twist. ShadowCam isn't your typical camera. It's 200 times more sensitive than conventional lunar cameras, allowing it to capture images of areas usually shrouded in total darkness, like the craters at the lunar poles. One of the first places it focused on was Shackleton Crater. Imagine Shackleton as the eerie corner of an attic where you suspect something strange is lurking. But here's the surprising part. No ice was found. This is puzzling because scientists were nearly certain that these shadowy craters would contain ice, especially after India's Chandrayaan-1 mission detected frozen water up there. Yet, Shackleton turned out to be dry. Only rocky ridges and the faint trail of a boulder that had rolled down the slope, possibly millennia ago. So what's going on? Why is it behaving like a desert when it should have hidden ice beneath the surface? NASA's ShadowCam continued its search, scanning more craters, but the results remained the same. No ice, no frost, not even a frozen puddle. And just when things seemed like they couldn't get any stranger, India's Chandrayaan-3 mission added an unexpected twist. Launched in July 2023, Chandrayaan-3 made history by being the first mission to land near the South Pole. It carried a rover named Pragyan and a lander called Vikram, and together they began exploring for signs of water. The hopes were high. After all, Chandrayaan-1 had already suggested the presence of water. But once again, there was no cooperation. Pragyan's instruments analyzed the soil for hydrogen, a key component of water. Instead, it discovered a mix of metals: aluminium, iron, titanium, and even sulfur, indicating past volcanic activity. But hydrogen? Nowhere to be found. Not even a trace. Let us know your thoughts in the comments below, and don't forget to like and subscribe for more updates.